this
Go ahead.
So let's say you have to do a video transmission over big networks, right? So rather than transmit, now we are thinking rather than transmitting videos from, let's say, Seattle to New York or this, right? Server, wherever server is. Just send the prompts and video generated the end device.
Yeah, but the only thing with that is at this moment there's no like reproducibility to it. You don't know what will get generated at the other end.
But there are users who want different entertainment type things also.
Right, yes. For them, editing is, yes. Okay. Yeah, there's a very creative uses. Actually, now that you bring it up, it's possible.
Because typically upgrading a network for this video, right? I think costs $5 billion a year.
That's true. That's true.
This a little efficiency improvement will
make a huge difference. Yeah.
Wow, the portal has changed since last night.
Yes. You saw it. Okay. Yeah. All right, guys. So today, while others are coming in, and just to be, and I apologize, but I would like to give you a sense of where we are going. See, we have two sessions. Today, we are going to give to a very entertaining task. You have a job to break the next team, whatever the next team creates, and your job is to make sure that whatever you build is absolutely unbreakable. Right? So you will wear the hat of attacker and defender at the same time. You have to build something. What you build has to be absolutely rock solid. And while you have built it as a team, you have to go from room to room and just go break everybody else's hack it, and prove that what they did was completely not good enough. Does that seem reasonable? This goes to the topic of adversarial attacks and defenses. So we will do a few foundational research papers on that. But before we do it, let's do this. I'll frame the problem in a little while, and but I'm just waiting for everyone else to show up. Then we will launch onto this exercise. The whole morning we'll give to that. Once you have done that, then we will take the lessons learned as a backdrop for you to go deeper. I'll take you deeper into why it was very easy either to defend or to attack. Right? Whatever your findings are, and we'll share our findings. Does that seem, how many of you are excited about the idea? Today is the day to legally hack each other, right? Break whatever the other team has done. Right? So we'll do that. Now, next time is code generation. Next is also the last session. So last session, what it means is that in the evening, we'll have our, we'll give you the certificates and so on and so forth. You'll find it in the course portal. And we'll do a little pebble. And for some of you, perhaps this is the last course. For many of you, this is the road forward. So people have been asking, what exactly is the road forward? So I thought I'll give you guys a sense of what the road forward is. But before I do that, I'll just take a minute. I just realized I left my reading glass in my room. I'll get it. The code generation.
Yeah. I thought this is the last one.
Today is the 11th class, isn't it? Yeah. Yes. So, guys, this field is exploding, and one of the challenges you have, obviously, you have great difficulty in trying to catch up with it, isn't it? As an educator, you have even greater difficulty because if you're going to teach this, you have to do curriculum development, which is usually, imagine writing a textbook. It takes far longer and more effort to write a textbook than to read it. You have to word it carefully, think what to teach, what the level is right, whether it's explanatory or not. In the same way, curriculum development is a little bit of a, and so I am also on the treadmill, like all of you, trying to do the curriculum development. So there are quite a few lessons learned from what we have been going through, and I'm going to walk through those lessons. I noticed that in the current batch, and every batch is different, we had, and this is what I've been observing over the many years that I've taught this course, these courses, especially at the university level, like when I used to teach at UC Berkeley or Urbana and so forth, the predominant audience would be technical. But progressively, I'm seeing that over the years, you get a lot of leadership people, people who want to have the strategic thinking, the big picture, the business use cases, and so forth. And for me, it was a bit of adaptation. Now, a little bit of a personal thing. I'm also, many of you know that I'm also doing a program at Wharton Business School. And so there also, I do give a few talks regularly. And I'm realizing how much need there is to have two different tracks to each course to cater to two different sort of audience. So going forward, what you'll notice is that, for example, the same course that you have taken, it will be split into two tracks, a leadership track and a core engineering track. The leadership track will be meant for people who are founders or in leadership roles in companies, who are basically saying, how can we, what's the value proposition of everything that we learn, and how can it help solve real world problems in our organization? So for those architects, VPs, and so on and so forth, we haven't catered enough. So the next version of this course, you'll notice, is that we'll have a material and stuff for them. Now, for the core developer track itself, I notice an interesting sort of a split. Many of you have done development. You want to be in the development track or come back to development track, but you struggled a little bit with the Python language itself. You struggle with setting up the AI environment. So I put two completely free courses that will be a precursor and that you can take on your own time, but will also give you guided sessions on that. One of them, and this one is Python development best practices. This comes from many of you requesting that, we know Python, we have been doing Python, but the way you write Python is rather different from the way we write it. So can you show how to think like that and how to write code like that? It's a short exercise and a course. We can put it, I'll put the material there very shortly as self-learning, but at the same time, I will give a one-day session before every bootcamp starts in which we'll walk through it if you prefer a more interactive form of that. And if you have seen the solutions, you have a sense of what I'm going to talk about. The other course is setting up the AI environment. I realize that many of you are not familiar with Unix. Especially, and even if you're familiar with Unix, you often use Ubuntu. Ubuntu is a great for desktop. It's a little bit more troublesome to go to production on Ubuntu because in terms of sheer security and reliability, Ubuntu's trade-off is more towards being user-friendly and very beautiful UI rather than a rock solidness. So that's the general perception, though that is debatable at this moment. So we use Rocky Linux, which is Red Hat Linux. And people are not familiar with concepts like Docker or orchestration of Docker, Docker Compose, Kubernetes, Unix shell, and basic things like pipelines. So this setting up the AI environment is again a very short mini course, self-learning, but we'll also give a one-day to it for those of you who are interested. Again, both of these will be free so long as you're enrolled in some bootcamp where you need this knowledge for you. And we are also decided that we'll give you for the coming Bootcamp, LLM2, will give you Docker images with everything set up in it. My general belief was that you should learn to set up things on your own, because that's part of the learning thing. When you go do a startup, people won't serve you the environment on the plate. You'll have to set it up. Most of you have gone through that learning in this first bootcamp, and now the time is to make rapid progress with the subject matter and go deeper into that. So for that, for each of the problem sets, you will get the AI environment. Now, other than that, the rest of the material actually is bifurcated now into many tracks. And each of these, like let's say that the one of them, which is part of your LLM2, is these are the topics you learn. The first thing that will happen is when you come to this course, you will have to take an assessment, simple assessment. It is self-assessment. And based on the self-assessment, you need to determine which track suits you more within this same course, whether you want to be in the leadership track or whether you want to be in the developer track. Now, neither of the tracks are easy. If you're in the developer track, you will have to do a lot of coding. And because now that you have in LLM1, it was a little bit a shallow introduction. Well, I wouldn't exactly call it shallow, but fairly substantive introduction, but to a much wider variety of topics. Going forward, we want to take you, and only the ones who are inclined to do development, we want to take you very far. And this is one of the experiences we learned in LLM2. The current batch that went through, we had to tread the middle ground between leadership and developers. A middle ground, we realize, perhaps serves nobody. The leadership people feel that we didn't have enough case studies, and the developers feel we didn't do enough labs and programming exercises. So now going forward, when you come to LLM2, to any of the courses, like for example, the art and craft of prompt, right? What used to be called prompt engineering, but now is a much wider subject, then you have to pick your track. If you are in the leadership track, you will still learn each of the topics that you see here, but you will be case studies based, scenarios based. You will get real world problems in your workplace. You'll have to either think it up or do it. And you'll have to sit in small groups and propose architectural solutions without necessarily writing code and debate with the pros and cons of those ideas, right? So imagine that you are the CTO or the chief architect at your company, and you're trying to determine what can I do with this technology? And you have access to developers. Once you create the high level strategy, they will execute, then that is your track. The second track, of course, is the core developer track, where now we'll go much faster, much deeper. And by faster and deeper, I mean that if you feel LLM was, frankly, LLM was a walk in the park. I hope you all felt that, right? It was very easy, isn't it? No? Any hands for that? No. Okay. I'm joking. But LLM2, guys, I just want to say, is much more code-based. You'll go much deeper in every topic when you do LLM2. Now, how deep you go, by the way, I was being jocular. Don't get scared. Right? LLM2, how deep you go is up to you. Like there will be a beginner's level core developer. There will be an intermediate level core developer, and there would be an advanced level core developer. And the assignments, the coding, the projects will be broken up into beginner, intermediate, and advanced. The expectation will be that you will actually finish at least the beginner's level to get a certificate of completion. And even the leadership would be expected to do the beginner's level, which will be fill in the blanks and repeat after me kind of coding, very basic coding. The intermediate level, I expect all the core developers to do. And the advanced level certainly would be a bit more challenging, but very rewarding. Some very, very interesting projects will be there. So we will follow that kind of a track mentality and a partition mentality. So we'll expect that you form your teams accordingly. Even if you're in the developer group, you decide like, are you guys going to be the developer, the basic team? Are you going to be the more advanced team? Or what is it that you want to be? So the courses that are coming up, in a way, may surprise you. You may say, hey, I know prompting. I learned about CoStar. How many of you feel you know prompting? Well, everybody feels they know prompting because, even kids are using ChatGPT. We went a little bit further with some basic frameworks like CoStar, etc., and chain of thought and tree of thought. Yes. But now, as you go into LLM2, you'll realize that that was just scratching the surface. We will go very, very deep into prompt engineering and pick up a lot of things there. So that is one course.
Can we give a day on this Copilot?
Yeah, that will be part of Python.
Okay.
Python. When you come to Python and you look at what are the best practices, one of the best practices I would say is you should always use a good coding assistant, Copilot, whichever one you pick, Cody, Copilot, etc. And we'll give you guys a session on how to use Copilot effectively.
Yeah.
Because nowadays coding is prompting. You write a good prompt in your Visual Studio Code, and it will generate the code for you. And then you review the code and decide whether you like it or not. So that is that. That will be the first part of your LLM2. After that, you will go into advanced RAG techniques. You have learned RAG, but you have just sort of scratched the surface. RAG is a big field, and it is perhaps the most used application of generative AI. Nobody would argue with the value or the utility or economic common sense of using RAG in their organization. Whether you are in the fishing industry or you're in the aerospace industry or oil and natural gases or healthcare or whatever it is, right? Finance, you need RAG. But RAG has exploded. Frameworks have exploded, tools have exploded, techniques have exploded, and research papers have exploded. So,
with the models able to take in more and more context, longer context, is there still a value for that?
Good question. Vasanthi asks, with the context length, the fact that now machines can take, for all practical purposes, near infinite context, is there still a need for RAG? Who would like to answer that?
If you have private data, then essentially then at the point that's not exposed.
You can still put your private, as long as your model is confidential, you can put that private data onto your property, if it's in your property.
But RAG is specifically for search content.
Okay, how about this? Let me park this question. It's a very good question. Right? Hint, pandemic. How could that be a hint? Okay, we'll think about it. But let me park it for a moment, guys. So you will be doing it, and the LLM2, you'll go very deep on that. And by the way, you will build something. You'll actually build a startup or mock startup, at least an open source project that you'll park. That's what you'll do. Real world. So now your skin is in the game. Your reputation will be on the line. You're putting it up there on a GitHub as a team project. Now, many of you are on a different journey. For you, the taking model, you say all of this is very good to do in Jupyter notebooks and on Visual Studio Code. How in the world do you take it to production? Right? So that is the whole topic of LLM Ops. Again, LLM Ops has two tracks always. You can be in the leadership track, the guy who runs the LLM, the Ops, machine learning Ops organization. And how do you set up in a startup a proper framework, a proper pipeline for doing that, and the actual doing of it. It will cover, this field has exploded. When you are practicing it, like the day-to-day reality that I'm giving you. See, think about a normal software development. You write code, we are all become good at CI, continuous integration. What does continuous integration mean? Pull requests come, you keep merging it, your code gets built, right? You put it through the sonar analysis, the static code checkers, you put it through the unit tests, you put it through the performance test, you put it through the scalability test, you do the security scan. If everything passes, you do what? You produce a binary. Right? Continuous delivery means every so often, the moment anything gets fixed, or every night, you do a blue-green deployment or something, some form of continual deployment. You replace the existing production version with the next version. Does it resonate with you guys? Are you guys doing it? Right? For example, in the organization that I used to run, my team, the IT, we used to have, someone once asked, how many releases do you do every year? And I looked up into the sky and I said, we do typically 3 releases a day. And the person couldn't believe it. How is it possible? Well, those of you who know continuous integration and delivery know, of course, yes, that this is exactly what you want to do.
Main branch is always usable. There's only one thing.
That is right. And then you keep on like merging into it, taking it to production, and you keep doing staggered deployments across your cluster. Right? And Kubernetes and technologies like this make it very convenient to do that. But when you look from the perspective of AI, this is all too easy. We have perfected that. How do you extend that pipeline to large language models? Anybody could point out to what extra complications there are with large language models?
Is about the earlier part, release part, is it?
Yes, go ahead.
So now,
Okay.
1 second. Guys, please mute yourself. All right, go ahead, Sachin.
so Spotify has about 1,000 services internally behind the service, right? The Spotify service. And where they are going with this, there is no way that they can do a coordinated release ever, right? It's the service has to be up all the time.
Absolutely.
And they have to come up.
Hmm.
So the way they are doing that now is every service, the developer has to own it, build it,
End-to-end.
maintain it, and release it.
Absolutely.
So there is no DevOps in the company. The way that they are doing it is all of that is automated.
Within one group, yeah, within one
group.
yeah, pod.
So these
Absolutely.
1,000 things,
Yeah.
so you have to, anything goes down, you have to be there on the production system, not even on the regular one. So that
Yes.
is that's the only way they can scale up and keep the thing running. And their whole idea is, we don't want this mentality of DevOps sitting whole night trying to do a release, because it is too much what you call
Stress.
pressure on them. And every developer system is different. So you own the service, you build it, you maintain it, you deploy it. So that is where I was saying the ML ops, why it's important.
That's it. No, thank you. Thank you for sharing
I
that.
think actually AWS in some teams they do that better. Not
Yeah.
everything.
Everyone is doing it, like more or less. To Sachin's point, very good point. See, guys, we live in the microservices world. So one little pod of 5-6 people own a couple of microservices, a few microservices. They vertically own it. They own the release engineering of it. There is a site reliability engineering that makes sure that everything is up. If anything goes down, they'll inform the pod. But beyond that, a pod needs to vertically integrate. I used to follow the same thing. So people had pager duty alerts. Does not matter what your title is. If a pager duty alert comes, like if it gets escalated to me, it means people have been sleeping, right? And I had to get onto the desk at 3-4 in the night, pull my team together, and literally fix it, find out what happened, and fix it. So that is the norm. Thanks for sharing that, Sachin and Ramki. So it is the new norm, and people have found that that is the most effective way of doing it. Netflix does it. Everybody does it. Wherever you see the microservices architecture, you see this this sort of an ecosystem thriving. So my question to you now is, so what is so special about LLMs or this AI world? Isn't it just regular?
No. Horizontal scale is not possible. Vertical scale, unfortunately, is required because of GPUs. You get more and more powerful GPUs, but you can't just split it into multiple jobs. So
excellent point. Excellent point. So, in other words, the hardware considerations are vastly different. Thank you for pointing that. And as he mentioned, in this world, microservices run on commodity hardware. Right? Typically, you would take, if you look at your AWS and your GCP and your Azure accounts, you will notice that your lovely code is running on just some 4 vCores, right? And with 16 or 8 GB RAM but there are 100 instances of it or something like that. Scale elasticity. It will scale from 4 to 100 instances. And then on a Kubernetes cluster, you can have hundreds of pods running on it. That kind of a thinking, which has become the de rigueur, pretty much the dogma for standard software engineering, does not work for AI, and it does not work because GPUs are a scarce resource. They cannot, it's not easy to break it down and basically say that this inference can be run on a tiny 4-course, a 4-week course or something like that. But typically to run an inference, it's a whole brain activity. The whole GPU is involved. To run an inference, sometimes not just one GPU, but a bank of 8 GPUs are needed within a server before one inference will go through. It is quite intensive. And so the whole dynamics has changed. That is one reason. Was somebody saying something on the Zoom?
Hey, Asif, so recently looks like Microsoft has released some smaller LLMs, like we don't have to use large language models. There are like uh, smaller LLMs which we can use.
Yes, that's true. 5.1, 5.2, 5.3, starting with the landmark paper. Textbooks is all you need. Very good point, Prashant. We'll talk about that. But the point is that it caters to a small minority of use cases, unfortunately. It does not cater to a vast amount. So that comes under the umbrella of what I call tiny titans. Right? How can you use this tiny LMs, you fine-tune them, specialize them, and do things? That itself is a big topic of, and then using them as a mixture of experts or using an ensemble of them to get your problem solved. It is there, but it does not change the mainstream problem, Prashant. The mainstream problem is, how many of you have installed Llama 70B? Llama 3 70B? Not one of you in this cohort. Okay, guys, hang on, before I take any more questions. Guys, Llama 8B, all of you, I hope have tried. It's a simple command, Llama run Llama 3. One liner that I trust all of you have run. Yeah. You realize that it has limited capacity. It does not produce long answers. Then you go to Llama 70B, 4-bit quantization, you can run on your GPUs, the ones that I've given you guys. Run it. Please run the Llama 70B. But as you will realize that as you try to run bigger models, the good answers come from bigger models. It's unfortunately still a fact of life. Those bigger models need more hardware, and they need the whole of the hardware. Right? So that changes the game for LLM ops. Ranki?
Yeah, that makes sense. Yeah, Llama 3, this standard Llama 3, we're able to run on 32 big RAM. That makes sense. Yeah,
RAM or a 4090 and so on and so forth. So that is one consideration. Why else do we need to do? So we can use the same methodology, just tell the purchasing guy to go get more powerful hardware and continue with the CI/CD pipeline practices. Why? What is so special about LLM ops?
Doing more with less hardware.
Well, that's always something that the cloud economists will push down on you. They'll always say, do more with less. Ideally, do everything without asking for any more hardware.
So going back to some sort of this pinning model like this, right? GPU, you have to pin to a particular type of GPU if you want the best performance. Right? You can't just run anything anywhere.
That is a good point, Santi. That is one. But in other words, you may have a heterogeneous GPU environment. For example, if you look at Facebook, Meta, they have generations of GPUs. They have A100s, H100s. They have some in-house GPUs. They also have A6000s, smaller ones. Right? So people contain a heterogeneous mixture of hardware. And how do you allocate jobs to those? That is one. What else?
Multi-threading is
multi-threading is like ancient history. Everybody has figured it out.
Yeah, but in GPU, multi-threading is a different thing.
Good point. Very good.
So,
I tried to distract you. You held out to it.
Stuff like Racer will basically queue the request so that it's one by one.
No, what happens if 2 requests go through it at the same time?
I haven't done that, so that's it.
See, guys, the most precious resource in a GPU and the single biggest determiner of the price of a GPU is what?
Memory.
Yeah, the HBM, the high bandwidth memory. 4090 has 24 gigs. H100 has 80 gigs, 80 or so gigs. Then the 130 that you're talking about is the Instinct, the AMD Instinct series. And now there is a statement that NVIDIA's latest Blackwell, how much does it have? Anybody remembers? I heard numbers like 3. They haven't announced it officially, but I hear numbers like 3 plus 350 plus minus something. Anybody knows? Blackwell 200, B200? Nobody knows. Okay. But yeah, it's the biggest contender. So what happens is if you run an inference, imagine your 4090. When you run an inference, have you noticed that what is the most common error that you get when you run your AI jobs?
Out of memory.
CUDA out of memory. But what is worse is once you have a CUDA out of memory, basically the train stops. After that, no more inferences run on the system. It is the hell. Right? So what you have to do, you have to guard your GPU and make sure that you never overrun the capacity of the GPU. But at the same time, you don't underutilize it. So you look at the job, you need to know that on this GPU, what should be your mini batch size, right? That you can push through. How many requests can you push through at the same time? And what you want to do is use a producer-consumer mechanism so that requests get queued. And from that request, you take that batch size of jobs and pass it through the GPU. Are we together? You don't want to underutilize, you don't want to overutilize. Those are important considerations. Other considerations are model management. You keep training the model because new data keeps coming up. Why do you keep training the model? I have the model, I've trained it once. Why would I keep training the model tomorrow, day after, and so forth?
Because
data
the data changes, the real world data
changes. Exactly. The data keeps changing. Also, those egghead blokes in your organization with their PhDs, what are they doing? They're finding cleverer and cleverer ways to make the model better. And not only that, there's hyperparameter tuning. As you explore the hyperparameter space, you come up with better and better models. So models keep evolving. They evolve in response to new data. They evolve in response to hyperparameter tuning. They evolve in response to organic algorithmic improvements, the neural architecture improvements. But models keep getting better and better for the same job. At the same time, data set keeps coming in. Data, you have to have a data lineage. Which version of the data are you playing with? Okay. So the version of a model now is a multivariate thing in its own right. It's contextualized on when how recent was the data it was trained on, what features it was trained on, what were the hyperparameters, right? And internal architecturally, how did it look? At the same time, data management. You cannot train data with privacy information. To scrub data and make sure that you have removed all of that is important. That PII has been removed and so on and so forth. Then orchestration of the whole pipeline. Industry runs on pipelines, machine assembly line production. What's your assembly line? Assembly lines in software are called pipelines. What are your pipelines? And there are technologies like Kubeflow, etc., that you use. People keep engineering better and better features for machine learning. And so that's the feature engineering. How do you store your features? You'll learn about frameworks like Feast and so forth. And then lastly, the memory hierarchy and handling limitation. Suppose on the limited number of GPUs, you have to run 100 different models. But at any given moment, you're getting requests for only 6 or 7. You don't know which 6 or 7 models are needed. How do you unload models dynamically based on need? How do you make sure you don't run out of memory? That's the world of MLOps. It's a very interesting. How many of you, by the way, are interested in the MLOps? Or one hand I know, which is not being raised. Okay. Right? You guys all are interested in that, right? Yes. So
I'm interested in everything, but I can't.
So you'll remain partially ignorant. That's all right. Guys, see, this is the whole reason I broke it up into parts. Pick that which matters to you. If it doesn't matter to you in real life, like for example, if you know that there is another LLM team, right? LLM ops team, then why bother? Then, LLM ops will make you do a lot of Ray framework and things like that. What's that?
No, yeah, it just many of us seem to like that a lot.
Yeah, Ray framework is amazing. It's the new Spark.
Yeah.
The same guys who created Spark created Ray.
It's almost Kubernetes plus, right?
More than that, it's more of it will eventually become a Spark replacement. Not yet, but eventually. Spark is ancient. It's beginning to show its age. Yeah. Go ahead.
Asif, this gadget, I'm still on the road. I have one question. Still, we are talking about the future LLM bootcamp thing, right? So lately, this knowledge graph is getting attention. There is a lot of things are going on, but it is in conjunction with the RAG. So are we going to cover that in the LLM?
Absolutely. It will be. Advanced RAG is a part of LLM2. LLM2 at this particular moment is the standard courses you do prompt engineering and advanced RAG, which contains knowledge graphs. Right? But you do have a choice. Like if, for example, somebody says, I don't want to do RAG, you do have a choice to pick other electives or do other electives on your own, like along a register for the other electives. But yes, knowledge graphs you can't do RAG nowadays without knowledge graph.
Asif, Krishnan had his
Oh yeah.
and
Okay, sorry. It was on a previous topic, but since a question, so the machine we have 4090 has 24 GB, right? The high bandwidth memory.
Yes,
How
right.
are we able to run the 70 billion parameter model? How does it?
Because we have an inference server with 4 4090s.
440. Okay, so you're basically distributing the model.
That's right.
Yeah. Okay.
Yeah, we have that, and we also have. Remember, in each of your case, you can 4-bit quantize it.
Right. Okay. Okay.
That's right.
All right. Thank you.
It's very good. Just yesterday, you missed that. Krishna, you were here yesterday. You saw the demo that Sukhpal made of the 70 billion parameter Llama 3 running on his machine.
Yes. Thank you. Yeah, I remember that. Yeah.
Yeah, that's that.
So one question from my side. Function calling seems to be
advanced RAG.
Okay.
What we are going to do, Madhu, function calling will look lame. Our point will be to throw away function calling and say, the time has come and gone for function calling. We'll do far more powerful techniques. Since you're asking, right, you'll do a new generation of, actually, I haven't put it here. You'll do a whole new generation of RAG techniques that completely wipes out the old style and prompting that wipes out the old style. So, it is with great pleasure I tell you that everything that you have learned in this course is gone. No, I'm kidding. No, I'm kidding. Good time to ask for refund. Okay. The next thing is AI agents. Agentic reasoning is the heart of where we are going now. If you pick up any computer science textbook on AI, the great textbook of Peter Norvig and so forth, literally called Artificial Intelligence, which has been the de facto standard for gazillions of engineers over the years, you'll realize that after the introductory chapter, which is review of basic concepts, prerequisites, the first real chapter is on agents. So it has been. Artificial intelligence has been all about agents. And now, with the LLMs, we are finally reaching a point at which this dream of agents is coming true. Every problem can be solved with multi-agent coordination, with ideas like multi-agent coordination and mixture of experts, and coming together of many, many important ideas and toolings. Everything that you can do, the actuators, the sensors, etc., you can consider them as tools. You will do that. And as you do that, you'll realize that we have, and the current batch has gone through some of them, but it is becoming even deeper and richer now by the day. For the people who did LLM2, one second, Vasanthi, the people who did LLM2, I just gave them a very quick introduction. I was not happy with all. They got introduced to QAI and AutoGen and MemGPT and Gorilla LLM, Llama Index, a little bit of it, but we didn't do it to the same level of depth and rigor that I would have wanted to. So I've carved out AI agents as a 6-week course of its own. Right? So each of these courses, guys, that you're looking at is a 6-week course. Your LLM2, to the extent that is built out of prompts and advanced RAG, is simply 6 weeks plus 6 weeks. 12-week course. But the other courses will run in parallel with it. So those of you who are interested can optionally register for those courses. Vasanthi.
Yeah, assuming the answer to my previous question that in spite of infinite context, RAG is still important.
I don't know. We'll debate that.
Yes. How does AI agents affect the future of RAG? Is it will it also add?
They're
add
orthogonal
value from-
topics. See, agents is more foundational, more deep. RAG is a specific technique. Agents is a more fundamental. It's at the core of how you think of AI to work. It's more foundational to AI. So irrespective of the fate of RAG, this will stay.
No, the question for me was reverse.
Okay.
What is the fate of RAG if this comes in?
Oh, no, this is not going to affect RAG at all. It's, if anything, amplify it.
Interesting. I'll post this video. Go to Google Next or even AWS. All the conferences, what use case you talk about is RAG.
Okay.
Other security technology.
Okay. Nice.
I understand that's the case now, but with agents coming along and infinite text, what is the value?
At least my feeling is going to be there like that for doctor.
Okay, how about that? Let's park it, right? I said we'll debate it. So be a bit patient and we'll come to it. Okay. So guys, the last topic, there are only two more topics, which are specialized fine tuning. Those of you who believe that models can be, I took you guys through some basic fine tuning, right? Now, if you want to really learn fine tuning, it's a whole world in itself. It has its own management and leadership and developer track. It's again a 6 weeks program. There can be people who are doing LLM too, and they may say, hey, I want to do prompting. Prompting is the basic I expect everyone to do, because the people don't even know what prompting has become. It's moved so fast. So you could drop RAG, like for example, Vasanthi believes RAG is gone. So can drop RAG and do instead fine tuning or something else. And then lastly, there is geometric neural networks. What in the world are geometric neural networks? A classic example are the graph neural networks. Right? And graph neural networks are the ones making the biggest discoveries at this moment. Literally, the biggest discoveries of 21st century are coming from geometric neural networks. Drug discoveries, cure for diseases, discovery of new materials, deep security analysis, anomaly detection. Everything is coming from geometric neural networks. If that interests you, there it is for you. So this is the scope of the courses that are coming up, guys, in the fall. And if you are interested, you're most welcome to register for them. Have you heard there's a saying in Hindi? How many of you know Hindi? This is a class of Tamilians, so it's an unfair question to ask.
Can't speak.
Okay. There's a saying in Hindi which says, Andher Nagri, Chaupat Raja. Would somebody like to finish it? Mridul, you probably know this. Andher Nagri, Chaupat Raja.
Yeah, I remember it. I can't recall it, but yeah, something.
Takeser Bhaja, Takeser Khaja.
Yes.
Means there was an ignorant kingdom with a hopelessly stupid king. He priced everything the same. Takeser Bhaja is ordinary food, and then the sweets, they were all priced the same thing. So we are in that kingdom. So every line item that you see, every item that you see here, every course that you see here, the unit price of all of them is the same, because I don't know pricing. So I priced it everything to be the same size and the same price, which is $1,600. So LLM 2, because it's made up of 2 units, 2 foundational units, therefore is 3,200, which is the same price as your first course. Right? Does that clarify, guys, for you? Right? So anyway, I wanted to give, and now I notice that even the ones who had traffic jam have showed up here now. So it's a great time to start. Thank you for letting me introduce you to the upcoming courses. Let's get started now.
What is the schedule for these? Like,
for all of these courses, they'll all start in August.
No, I mean the days.
For you guys, the LLM 2 will continue to be on Sunday. Right? Which means that we'll start with the prompt engineering, right? And RAG. They will continue on Sunday. there will be courses that the other courses will happen during the evenings, weekday evenings. Some things will happen on one evening, the other evening, and so forth. And the exact dates, I have to figure it out. But if you are interested, now is the time to see, guys. You guys have an advantage in the sense that you are the first to know. I mean, as Raghuvi pointed out, we created this material just yesterday because we are in the process of curriculum development, and this. You get to register for it first, or at least send me an email you're interested in. Let me know. I can reserve a spot for you. After that, I'll open it up to everyone else next 3 months. So, guys, obviously, take as much as you can digest. Like, don't go and register in everything at the same time. Right? It might be you'll get burnt out. Basically, remember that, like Einstein said, the whole point that there is time is so that everything doesn't happen all at once. So, leadership track is there in every course. So those people in the leadership track who are not coding, they will get important case studies to do, and those would be very much like business school, like Wharton style. You will get a real world situation, a real company that had to face a real decision using that technology. I'll pose that as a problem. You'll try to solve that problem.
Is that it's also coming up along with this element too, or what is it?
No, it will be a part of that. So when you take any course, you can choose the coding track or the leadership track, or you could just hop between the two. Or if you want to be really, really busy, sit on both. So it's up to you. Does that make sense, guys? The reason I'm breaking out the leadership people from the coding people is because I want to move deeper into the coding for the technical people. And on the converse side, the other side of me, see, you remember that I also these days wear a CEO hat. So I give a lot of advice to startups on what strategic decisions are right and how to go about building their startup. So that audience comes and they say, why are you, I came to learn that. You're not spending enough time on that. So I want to bifurcate the two parts. Krishna, are you saying something?
Asif, I have a question. So let's say if I am interested in advanced RAG and the fine tuning, but it is falling in two different curriculum.
Right.
How can we do that?
It's very easy. You register in LLM2, which will see prompt. You can't do RAG without doing good prompting. The RAG that you did in LLM1 was good, but you have no idea how deeply, richly you can do it. So you need to learn prompt engineering properly. It's foundational to RAG. So you do prompt engineering and RAG, and then you register for fine tuning separately.
Okay.
That's what you would do. See, the reason these are separated is there are a bunch of people who will, for example, not care about any of the algorithms. They say, all I want to know is LLM ops and fine tuning, because my role is very operational. Right? I will be given data, asked to fine tune, and I will be asked to take other people's models to production, LLM ops. That's why these things have been broken out. People can pick and choose. Come again? Yeah. This is all in the fall season, guys. And the other thing is, for those of you who are going to tell your friends about it, LLM1 will remain the same. The only difference would be it will now have its leadership track and developer track, but much of the content will remain the same. The intro to AI, those of you who did, it was supposed to be 2 courses in sequence, like the theory part, which we just finished, and the lab part, right? Repeating exactly the same thing with the lab, the code version of it. But I realized that it stretches out the timeline quite a bit. You start in spring and you finish in end of fall. So now what I'm going to do is, instead of one evening a week, it will become 2 evenings a week. Tuesday will be theory, Thursday will be lab. Does that make sense, right? And for those, and of course, for you guys who have already taken the theory, you can attend only the Thursday part. And when you attend the Thursday part, I've standardized, as I said, the price. Everything remains exactly the same. No change, simplicity. So that is all I have to say. Okay, that's for the courses that are coming up. One request: if you liked what you're seeing, do refer it to your friends and family and your colleagues. Send them over. And now I'd like to address the question that Vasanti asked. And this question is being hotly asked, and a lot of opinions expressed in the industry. RAG, the days of RAGs are gone, right? I remember that somebody, some big luminary guy, I think was it Sam Altman or somebody also said, hey, RAG is just for the time being. Once the models become smart enough, big enough, you won't need RAG. Once the context windows become big enough, you won't need RAG. And context windows, sure enough, have become bigger. So let me ask you this question. Why RAG? Is it still any value in doing RAG? Who would like to answer that question? Blank slate.
I think at least one of the use cases would be areas of data completely private when
Data privacy. Okay, I'll keep writing all of your points. Guys, this is again a leadership thinking kind of exercise. This is, if you want to get a taste of what I'm going to do in the leadership track, exactly this. Think it through.
You have control on your own data.
you can go back to that CIA triad and security, confidentiality, integrity, availability. Data is still confidential with you.
No.
And also, you really don't want to spend time because there is also a time span. How long you want to, how quickly you want to take things to production. You don't want to spend that additional time in training, taking the data, and then fine tuning the model. Right? Fine tuning. Then that could be a good option too.
No fine tuning. Time to production is essential. Okay, so let me ask this question to you, Ramki. Time, data confidentiality. Hey, when you fine tune your in-house model, you still have data confidentiality.
No, absolutely. And
so therefore, defend your argument.
So my argument is the input data system is basically coming at a high rate, certain rate, right? And it takes time to fine tune the model.
Time. No, your second point is there, but I'm debating the first point. Debate your confidentiality and argue for it.
No, the confidentiality is the data in the enterprise, and that doesn't change whether you fine tune or do that.
That is right. So are you taking data confidentiality off the table from your argument?
Data confidentiality. So basically, what I'm saying is there is RAG or fine tuning. So basically, how would you do? Suppose you are an enterprise, right? And you picked up an LLM from somewhere, right? And now you're saying data confidentiality is super critical. There are two options.
So no, Ramki, before you go there, there are three possible options, not fine-tuning and RAG. What is the third option, guys? Vasanti, the one that you're arguing for. What is the third option? In context learning. So the choices are, remember when you debate it, the background choices are RAG, fine-tune the model with the new data, fine-tune, and in context learning.
I would like to add the cost factor too.
The cost, which is more cost effective? So you're pro RAG or to RAG or not to RAG?
No, I'm pro RAG.
Pro RAG. Okay. Cost. Enlighten me more on the cost factor.
So the way you pay for that the large LLM model, okay, it is based on the context window. So the more the data you send, okay, it is going to cost you more. So at the same time, like it is taking out some of the costs like from the RAG, but certainly like the advanced RAG is more effective in my opinion. especially
Absolutely.
like
No,
with the
it's a good
knowledge
point.
graph and other things.
It's great. It's great. I'm parking that point. I'm parking that point. It's a very good point that you raised. Mridul, you want to add another point?
So yeah, in the pro side, right? There's domain specific knowledge to solve your specific business problem. Right? That's where the edge is.
But you could fine tune the model on your domain.
No, but your specific business problem, right? May be different from even your competitor's business problem.
Right. Okay.
So we
That-
can, the other point is, we can reduce hallucination by using RAG, by grounding it in facts that we provide in the prompt.
Very good. Time to production, the timeliness of the data. These are things that are in favor of RAG. I guess timeliness, freshness of data, the stillness factor. Stillness factor is important. But see, guys, any more factors you want to park? Absolutely no. Vasanthi, you're not arguing for your point of view.
No,
What
I'm
about
waiting for
parts?
others.
Let's kill RAG.
By the way, if I actually want to lose this argument, because if I win, then I have to change my job.
Oh, goodness.
So, but okay, just playing devil's advocate here.
Yeah.
The data confidentiality.
Yeah.
Again, right? Microsoft Copilot, which I think a lot of companies are using now, they have licenses saying that you can use our model and your data is secure. You will not share.
Confidential computing. And
Yeah,
stuff.
so licensing agreements force them to say that okay, you can use our foundation model, but your data will be safe. On the cost factor, yes, token count is a big problem right now, but then that is a direct relationship to okay, you're using a lot of memory. Now, if you have infinite context, that problem should eventually go away.
No, because if your cost is proportional to token count, every time you send a large or infinitely large in context text prompt.
But that the reason why that cost exists is because you're using a lot of memory, right? Now, if the models are coming out saying they're using lesser and lesser memory.
No, you can't. You can't. See, the thing is, if you send a prompt, a string, which is, let's say, the Encyclopedia Britannica, there is nothing you can do. There's no amount of compression that will make a huge dent into it. Ultimately, that entire context, you're going to incur a quadratic cost there.
Top of it, that hyperscalers will condition you, right? So basically, like that's what's happening.
Okay, guys. So if there are no more points, I'd like to debate each of these, and I'll give you a perspective. You all are coming through, and this is the way you think, guys. See, someday you will all sit in decision-making meetings, and this is a taste of your leadership plan. Data confidentiality. Go ahead.
Just one other thing. I mean, this is neither here nor there. RAG is like a means to an end. Right? Like if you look at Notebook LLM from Google, it might be using RAG, it might not be using RAG. You just use it because that's exactly the same thing you try to achieve in code.
Yes.
And like OpenAI assistant APIs, just right now, are they using RAG or they're not using RAG or using in context? So you basically get it done.
Yeah, basically it's a inbuilt RAG actually.
Exactly. Yeah. So we don't even know there's inbuilt RAG or
yes, what it is doing.
Yeah,
Yeah.
It's hard to like.
It's hard to
tell.
tell.
A Dropbox or you take all your Google Docs in your drive and then you do RAG on the fly. Using RAG, I'm just using the Dropbox API.
Now, this is a good point. See, at the end of it, remember that all of engineering architectures or approaches are means to an end, which is again the strategic goal. What's your strategic goal? And so long as that goal is being achieved, under the covers, which technique you use, at some sense, depends on what makes sense at that point in time.
Yeah, like notebook LLM from Google is very interesting. You just create nodes, like any other node, OneNote or whatever.
Yeah.
And then you check the node and use that node in context, right? On the fly. So so just kind of
in context learning, in context.
Asif, data control is one of the major important things.
So I'll put it here, data confidentiality and control, I'll put it. And Madhu is doing a PhD on confidentiality and security. Madhu, any more points?
Data control, when I say data control, is in the context of, for example, you have RAG implemented and you're continuously collecting the feedback loop, and you're going to be able to hold the data in-house rather than basically giving up through any means. So that kind of forces to go with RAG mode.
That's right.
Is GitHub Copilot confidential or not?
Yeah, you have a question. Is GitHub Copilot confidential or not? You have to answer that question. Now Microsoft knows what code every single person in the world is writing.
Yeah. So
they come.
I think it depends on the licensing of the lead. They can have.
No, let's not get, guys, we are going too far afield. I'm saying focus only on data confidentiality. Speak to that, argue for it. Why does data confidentiality at all matter in the RAG versus not RAG debate?
It matters a lot. When you need speed, RAG doesn't give you the speed.
RAG gives you lightning speed. When it comes to speed, in fact, the argument in favor of RAG would be speed is inarguably the biggest reason in favor of it, and I'll explain why. See, guys, today search engines, when you use a fast index with HNSW, whatever indexing technology, let me give you a measure of how fast it happens. You can have hundreds of billions of images and documents, and yet your query response time is millisecond, right? Companies, social media companies, and I know it from real, it's the same. Literally, they will send out alarms if the number of queries processed per second, full-fledged queries processed per second, goes below, well, it used to be 600, nowadays 1,000. If you process less than 1,000 queries per second, quite literally, alarm bells go off. Right? They process tens of thousands of queries on a cluster. They potentially can. So whereas if you send the same information in the prompt of a LLM, you will notice, and this is something important, you will notice that suppose you do in context, that is the prompt. People say prompt, and this goes specifically, Vasanthi, to your point. If you add a lot of data to the prompt, what happens is that the response time is linearly proportional to the length of the tokens. The longer the token length you have, the slower the LLM can respond. And it goes to the quadratic nature. Remember that. What is the QK? You remember that you have the softmax. What's the formula? Right? So what do you have? Here you have a dot product, the quadratic dot product, right? So the bigger the context length, the bigger the prompt, the more horribly expensive the query is. Whereas RAG suffers from no such problem.
But what are we doing with when they say infinite context? I thought we were making
infinite context is all right, but it doesn't see infinite context just says we can handle infinite context. It is silent upon how expensive it will be to handle infinite context.
Asif, the UC Berkeley announced yesterday they've done some good metrics on the similar lines. The latency and the cost for Llama 3 is kind of outbeating everything else. It's less than 0.13 second is what their benchmark is showing. So just thought I would add that because those are two major.
No, that is nice. But see, Madhu, I'm asking you, irrespective of how specifically fast or slow one particular LLM is, it is a fact that the longer the context, the more the compute. That is indubitable, right? I hope that we stipulate as a fact. Whereas when you do RAG, so hold on, guys, when you do RAG, that's not a problem because you'll just send 5 search results no matter what. Let us say, pick a random number 5. 5 search results no matter what. 5 chunks of data. You guys all did chunking. 5 chunks of data you're sending it. Do you realize that your invariant of your data set size, your RAG cost remains predictable and fixed per query? So when it comes to speed is in favor of RAG. But I want to go back and talk to you about the data confidentiality. It's important, guys. Huh? See, what happens is that, and that is specifically the topic of today, security and hacking. LLM, the mental picture you should have in your mind is, LLM is a 2-year-old child. Do you ever tell your child, 2-year-old child, the password to your banking account? You don't, isn't it? You don't tell a child sensitive secrets, not because you don't trust a child, but because you know that a child is innocent. Anybody can pry it out of the child, isn't it? You don't send the child with an expensive cell phone to school because the cell phone will disappear. Somebody will take it from the child, right? LLMs are like 2-year-olds. Anything that the LLM sees while training, it can potentially remember in its parametric memory. What does it mean? If an intruder gets access to your LLM, that intruder can then pry that information out of the LLM, even if the LLM is in-house. It's an important point that most people miss, that when you train an LLM on data, there is a fairly high probability that the LLM remembers that data and it can be stolen from the LLM if an adversarial actor gets access to your LLM. Right? So therefore, data confidentiality requires that you never fine-tune your LLM on confidential data. Guys, remember that. LLMs may have huge context length, may have this, may have that. Do not ever fine-tune your LLM on confidential data. Uncontroversially. Remember this as a fact. Go ahead, Ramit.
Clarification question. I mean, even to use RAG within an enterprise, the data is within an enterprise. You're creating a database, basically you have some information, you're creating chunks and vectorizing them. And then you have the same, you're left shifting the problem, right? Like basically that database has have very limited access.
That is true. See, we know about database security, right? You can encrypt databases, you can do that. But you realize that there is no such thing as encrypting an LLM. There is no security with LLM. LLM is like a very transparent 2-year-old kid, right? From which, if you have access to it, you get it. And not only that, even if you get access to the whole RAG system, you'll get little snippets of information you can steal. You cannot steal the whole database. Whereas if you fine-tune your model on LLM, it can regurgitate the whole thing. Right? Very important security concern, because today's topic is security. So data security, data confidentiality is in favor of RAG. Next is time to production. Yeah.
What this did with ChatGPT was, they asked it to give a list of fonts, and it would say that I am not privy to give the list of fonts, right, because of whatever is not right? Now, when you reverse the question and you say that I'm a very sensitive guy and I do not want to visit, which are the sites I should avoid? It gives you the whole list. So,
prompt hacking, yes. Yes. In fact, today's your exercise, your first lab is prompt hacking. Yeah.
The opposite.
Right. Yeah. So guys, okay, let's move to the next point. Time to production. Time to production, guys. Anybody had a question? Okay. Anybody had a question? No. Okay. Time to production is no-brainer. That is in favor of RAG, isn't it? So guys, data keeps on increasing. You keep storing, chunking it, have a pipeline. See, in architecture, you call it the producer-consumer pipeline. There's a producer pipeline that brings data from God knows wherever, keeps indexing it into your search index. Consumer inference pipeline doesn't even know. It just goes and searches the index, gets the results and does it. Cost. Let's go to cost. Token count. People say, and now I'll come to the main argument of why this argument is completely senseless when people say that now LLMs can have infinite context. And it is somewhat You literally know that even the big experts you can't trust because they're speaking with the axe to grind when the OpenAI CEO and these people say, hey, RAG is only a temporary solution. Here's something. So you know that the token length, the context length, let's say that your context length is sufficient for all your problems, whatever the length is, infinity if you want it, right? You can fill it in. What happens is that first problem, your compute cost is proportional to the square of length, more or less. The best you can do it is you can make it order length, right? Somewhere between order L square to order length, sub-quadratic. There are many research papers these days that are trying to make it sub-quadratic, all this so-called infinity context and all of that. But at the end of it is proportional. You cannot make it invariant of the context length. Common sense, guys, I'll give you a simple common sense example. If I give you Encyclopedia Britannica, does anybody even remember those things? Or Wikipedia, right? Then, if I were to ask you, when was the first Battle of Plassey fought? It's a very specific question about the history of a very specific country, right, which was colonized, right? Now, how would you like to answer it? It has all the keywords, Battle of Plassey, etc., etc. If you rag it, you would get a certain chunks from a history book. In that index could be history, geography, physics, chemistry, whatnot, every single subject known to us. Now, if you give it the entire Encyclopedia Britannica or Wikipedia, you agree that even the most super intelligent machine in the world that would come into existence in 100 years from now cannot avoid first reading the Wikipedia or reading the whole of the Encyclopedia Britannica, because the answer could be anywhere. Do you agree? So you have to do at least one linear pass through the entire content, isn't it? So you realize that you can never go sublinear. You can never break this barrier. Logically, you cannot break this barrier. Is that true or not, guys? It's true. It's true, right? And therefore, if you don't do RAG, every time in context, you would have to pretty much ship your entire Wikipedia or your encyclopedia and just say, find wherever it is, even if you solved all the problems. Now, there is a lost in the middle problem and many other things, which are becoming lesser and lesser of a problem. So people are saying, hey, all the problems are solved. What they're not thinking is with their, with their thinking head on their hats on their head. You cannot break this barrier at all. Then comes the question, compute cost is therefore there. And that compute cost is passed on to you. Now, here is a data point I'll give you. There are people who are shooting queries to OpenAI, who in their infinite wisdom send such a long context length that one query can cost a few dollars. And they are shooting tens of thousands of queries in long pipelines. The only saving grace is, and by the way, I myself, a member of my team at one time complained and said, there's a rate limiter, OpenAI is not letting us put more queries through the system. And I looked back and I thought, our query limit was somewhere in the millions of tokens, right, per hour or something like that. How did you break that? And it turned out that the person was shipping the entire body of knowledge in the prompt. Right? This is the thing that will make all this commercial LLMs rich. Yeah? Fortunately, and by the way, what was it? In a few hours, I raked up a few $100 bill. Right? Do you really want that? Is that a sensible way to run a business?
I think these guys will come up with something called like a RAG as a service later on.
Yeah, it's already coming up. Cohere and all these people are giving it to you. So that is it, guys. So now another way I'll tell you. I know that you guys have questions. Please hold on. Please bear with me for a moment. See, guys, here's something. I gave you the clue word pandemic. You have to know something about human knowledge, and we don't ever understand. There are things that have exponential growth, right? There are many things that basically grow as e to the, let's say this is the time axis, that grow like that. One of the things that grows like that is knowledge. Let me give you an illustration of that. More scientific discoveries in many fields have been, especially in medicine, apparently, more has been made in the last 2 years, medical discoveries, and than in the entire history of medicine. In fact, in medical, they are saying that more has been discovered in the last 8 months than in the entire history of medicine. Right? Just think about it. In just about every domain, more, roughly speaking, more knowledge has been created in the last 2 years than the history of mankind. Now ponder over it. Just think a little bit about this. Human mind is incapable of grasping exponential growth. See, when the pandemic hit, germs grow exponentially. You know, I infect 5 people infect their own 5 people. It's an exponential growth. We all knew that if you have even elementary mathematical literacy, which by the way doesn't exist, just look out and see how many people buy lottery tickets. Right? I call lottery tickets a special mathematical idiocy tax. Right? So, considering our mathematical illiteracy, right, what people did is they argued whether the virus will spread or not, or what it takes to spread. All they needed to do is quarantine at home for 2 weeks, because that's the life of the virus, isn't it? If everybody just stopped dead in their tracks for 2 weeks, what would have happened? In 2 weeks, no scientific progress needed. The pandemic would be over globally. Instead, we lost hundreds of millions of people globally. We kept debating to mask or not to mask. People insisted that if God wanted us to mask, he would have grown masks on our head when we were born as babies. Right? And the pandemic raged on. Science happened to find a cure. Otherwise, we were like completely, the vaccine, otherwise we would have been completely lost. Half of humanity would have gotten wiped out. Goes to the fact that human beings don't understand exponential growth. Knowledge grows exponentially. You cannot drag an exponentially growing body. I'm sorry, not drag, given in context, exponentially growing body of knowledge and say, find my answer in this. Do you realize that? The cost will grow exponentially, because if knowledge is growing like this, what does it mean? Your cost is growing like this. Do you see this, guys? Is this common sense? Right? If it is proportional to context length and the context length is growing exponentially, you cannot basically throw in the entire encyclopedia, because the encyclopedia is doubling in size every 2 years. Right? That is the reason you don't. Also, never underestimate the power of retrieval. The whole field of information retrieval, search engines has existed. What does it do? It takes a exponentially growing body of knowledge and essentially makes it sublinear. It pretty much makes it to the log L, right? Reduces it down by a huge margin, or even below less than log N. Hash table, right? Inverted index, like this, and obviously when you do fast index, it does something very similar. It does a massive compression of knowledge and retrieval efficiency. When I say that in a fast index, you can literally run thousands of queries a second on a good cluster. I'm not kidding. And from there, to answer your question, only 5 or 10 bits of information are needed, isn't it? Therefore, that is the case for, again, case for RAG. Domain specificity, both ways, you can domain specific, fine tune a model, domain specific, RAG it. Right? On domain specificity, I would say that do both, not just RAG, but to fine tune. Are we together? Do both. Reduce hallucination. Once again, do both. RAG is very effective in reducing hallucination, but so is fine-tuning. It can help you do that, right? And not only fine-tuning, and in-context learning also. All three are good at reducing hallucination. Timeliness, no-brainer. If fresh news comes in, you want it to be part of your LLM, RAG it. You haven't had time to fine-tune on it, right? And speed, again, no question. So I hope I just managed to save the RAG scores. Okay, go ahead.
Follow-up question, like, even if you do RAG, take the output of the RAG and pass it as a context to the
Output of the RAG and pass it as a context to the downstream LLM for what purpose?
Basically, the additional context, right? Like, you want to get some final answer. No, sorry, not RAG. I mean, you
Search.
a database.
Yeah,
Some
search.
search.
But that is RAG. The classic definition of RAG is retrieval and generation. Retrieval is the semantic search and the hybrid search, and generation is the LLM.
Retrieval length itself could be long. You have to then make sure
You can make it. You can use the longer context to just feed it more search results. Good point. Yeah, you could.
But also just going back to that, like, fine tuning and RAG. Let's take a enterprise use case. So, for example, like, two roles in enterprise. One is an admin and non-admin. Right? Admin has some, like, say he wants to train some more confidential. One, like you said, is if you do RAG, you build one model which is accessible to everybody, and then have two databases, right?
Yes.
One for that and other for this and
Absolutely.
other model could be, I mean, assuming you're willing to spend money and time, you could say I'm building two fine-tuning models, and one of them is accessible to the admin and other to others, right?
Okay.
That way,
that is coming specifically to the problem that I'm going to give you now, the project. Okay, guys. So now I'm going to connect RAG very much, Ram, to your point. You'll enjoy this, I think, today. Let's come to the project that I want you guys to do. Today in the afternoon, we'll read some research papers on adversarial attacks. So today's topic is adversarial attacks. Now, let me give a very short primer before I go into it.
So, after I ask a question before you go to one topic, the Olama model, right? It can allow you to locally run stuff.
Olama is not a model. Olama is a model runner.
The model, it allows you to keep your model local.
Yeah.
So how does it different from RAG? If I hold everything internal to my organization, I'm not able to expose anything to anyone outside except to specific query. How does it differ from RAG?
Okay. Gopal has asked a question that if Olama helps us keep models local, how does it differ from RAG? See, here's the thing. RAG is, let me again go back. And I suppose, when you take the RAG course, you'll do it much more carefully. The first step is step one, query comes, it goes to a search engine index, which may use both semantic search and keyword search to produce search results. Now what you do is you take the search results and you do this. You add the two, the initial query to produce, you produce something called input prompt. Plus, there is also one more thing, a system prompt, a system instruction. Three things go into creating the input prompt. System prompt says, use the information given here to answer the user query. And user query is whatever the user query is. Right? That's your system prompt. You feed it into an LLM to get results. This is your RAG architecture. So now this LLM can be either local or remote. It's totally up to you. It doesn't matter. It is still RAG. So when you use Olama, you are keeping it local. When you use OpenAI or Anthropic, you are shipping it up. It doesn't matter, but it is still RAG. Right. More and more, I would advise you guys to use local elements.
confidential.
Right. So that hopefully answers the question. All right, guys, what I'll do is, how about this? I stop this recording, give a 5 minutes break. You all need a restroom break. And after that, we start with the topic of the day. Any more questions on RAG?
What did you conclude? What RAG is here to live?
Oh yeah. So what was the conclusion? Is RAG here to stay? Vasan, we should ask Vasan too.
So I think I agree with all your points. I'm very happy I don't have to immediately look for a job.
Good.
But I guess the underlying assumption here is that the transformer architecture is very useful.
Yes. Oh no, that is not at all for sure. Transformer is already being superseded by newer architectures.
Then the thing that it's quadratic relationship may not hold, right? Depending on what
It can never be sublinear. The point of search is that search is sublinear. Right? No architecture